Hi, I'm Mark Bird, the Director of the Magnet Science and Technology Division here at the National High Magnetic Field Laboratory. And we're in the resistive magnet shop, where we build the world's most powerful DC magnets. We can show you how a basic resistive magnet works. This is a piece of copper wire that's been wound on a piece of steel. And then there's a battery in the circuit. And when the battery's put in, you have current flowing through the wire. It makes a magnetic field in the center. The magnetic field magnetizes the iron, and then you can pick up paper clips and things like that. That's a very small magnet. And the field at the tip of that piece of iron is about 0.01 teslas. The magnets we make in this shop provide fields as high as 30 teslas. To make a magnet that powerful, you can't simply make one like this bigger. And there are two reasons for that. One is it would overheat, and one is it would rip itself apart. So to build a more intense magnet, you have to deal with the heat.
Where does heat come from?
Anytime you put current through a piece of conductor, a copper wire, it generates heat, the same way an electric stove makes heat or a light bulb makes heat. So instead of using copper wire that's insulated, we'll use copper sheet metal. And so we have bitter discs here. These were first developed by Francis Bitter in the 1930s at the Massachusetts Institute of Technology. He used copper sheet metal, stamped lots of holes in it. He made insulators with the same cooling hole pattern, and by stacking these in an alternating conductors and insulators, you can make a helical pattern. You put current through it, high current through it, you'll get a high current density, you'll make a magnetic field in the center. But now we can pump cold water through all these holes and get a velocity up to 20 meters a second, which is about 45 miles per hour, and keep the magnet from melting.
The water goes into that big hole in the middle?
No, that's the hollow center of the magnet called the bore, where the magnetic field is strongest and where the scientists put their experiments. The water passes through these elongated cooling holes. This type of bitter disc, invented right here in Tallahassee, is now used at magnet labs all over the world.
Okay, so the cold water keeps the magnet from overheating. What keeps it from being destroyed by all that power?
In this magnet, the current is flowing around in circles. The magnetic field is perpendicular to those circles, and so there's a magnetic force outwards everywhere in the disc. And so to make these hold themselves together, we have to use very high strength copper alloys. So these discs, the highest field ones, are made from an alloy of copper and silver that's actually stronger than the steel that you see in the beams behind me, yet it has electrical conductivity 75% that of pure copper. So by combining this very high strength material, making these rings of conductor, providing a cooling system, we're able to get to much higher fields than you could with a simple wire wound coil.